The universe, vast, mysterious, and full of wonders. But have you ever wondered where it all began? The answer lies in an event of unimaginable power and scale, the Big Bang. Imagine a time when there was no time, no space, no matter as we know it. Picture everything in existence compressed into a point smaller than an atom, an infinitely dense singularity. About 13.8 billion years ago, this singularity began to expand. Not just expand, but inflate at an unimaginable rate, marking the beginning of our universe. This wasn't an explosion like a firework. It was the fabric of space and time itself stretching and expanding. The Big Bang is the foundation upon which our understanding of the universe rests. So buckle up as we take a journey through time and space, exploring the incredible events that unfolded in the first moments of our universe's existence. The term Big Bang can be a little misleading. It conjures up images of a giant explosion, but the reality is far more elegant. The Big Bang wasn't an explosion space. It was the expansion space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots get farther apart because the balloon itself is expanding. That's a bit like what happened in the Big Bang. The galaxies weren't flung outward from a central point. Instead, the space between them stretched and grew. In those first fleeting fractions of a second, the universe was a maelstrom of energy, a seething cauldron of unimaginable heat. As the universe expanded, it cooled, and this cooling was crucial for the formation of everything we see around us. The energy of the early universe began to condense into matter, the building blocks of stars, planets, and ultimately, life itself. This transformation from pure energy to matter is one of the most profound mysteries of the Big Bang. Right after the Big Bang, something extraordinary took place in the first fraction of a second. This phenomenon, called cosmic inflation, caused the universe to expand at an exponential rate. Picture a grain of sand suddenly growing to the size of the Milky Way galaxy. This rapid expansion smoothed out the fabric of space-time, which explains why the universe appears so uniform on the largest scales today. The afterglow of the Big Bang, known as the cosmic microwave background, shows a remarkably even temperature in all directions. This uniformity supports the inflation theory, indicating that the universe experienced a period of incredibly rapid growth early on. These ripples created the gravitational framework for matter to clump together, eventually forming the vast cosmic structures we see today. As the universe continued to expand and cool following inflation, the stage was set for another pivotal event: the formation of the first elements. In the first few minutes after the Big Bang, the universe resembled a giant cosmic soup, a hot, dense plasma of protons, neutrons, and electrons. As the universe cooled to a few billion degrees, conditions became just right for these particles to start sticking together. Protons and neutrons combined to form the nuclei of the first atoms, a process known as nucleosynthesis. The vast majority of the atoms formed were hydrogen, the simplest element with just one proton in its nucleus. A smaller amount of helium was also created, along with trace amounts of lithium and beryllium. These light elements, forged in the crucible of the early universe, would go on to become the building blocks for the first stars and galaxies. For hundreds of thousands of years, the universe remained a hot, opaque fog, with light unable to travel freely due to the constant interaction with charged particles. But as the universe continued to expand and cool, electrons were captured by atomic nuclei, forming neutral atoms in an event known as recombination. Echoes of creation, the cosmic microwave background. With the formation of neutral atoms, the universe became transparent, allowing light to travel freely for the first time. This first light, emitted just 380,000 years after the Big Bang, has been traveling through the cosmos ever since. Today we observe this ancient light as the cosmic microwave background, or CMB, a faint afterglow of the Big Bang that permeates all of space. Discovered in 1964 as a faint hiss of radio noise, the CMB is one of the most important discoveries in cosmology. By studying its subtle temperature fluctuations, cosmologists can learn about the universe's age, composition, and even its geometry. These tiny temperature variations represent the seeds of density fluctuations that would eventually grow into galaxies and galaxy clusters. The CMB is a treasure trove of information about the early universe, a cosmic time capsule that continues to reveal new secrets about our cosmic origins. The ever-expanding universe, a journey without end. The Big Bang wasn't a one-time event. It's an ongoing process. The universe is still expanding today, a discovery made in the 1920s by astronomer Edwin Hubble. By observing distant galaxies, Hubble noticed that they were moving away from us, and the farther away a galaxy was, the faster it was receding. This observation led to a profound realization. The universe is not static, but rather it's engaged in a never-ending expansion. The expansion of the universe has profound implications for our understanding of its fate. Currently, observations suggest that the expansion of the universe is actually accelerating, driven by a mysterious force known as dark energy. This discovery has revolutionized our understanding of the cosmos, suggesting that the universe's ultimate fate may be a cold, dark expanse, where galaxies become increasingly isolated from one another. One of the most incredible things about the universe is that it allows us to look back in time. Because light travels at a finite speed, the light from distant objects takes time to reach us. This means that when we observe distant galaxies, we're seeing them as they were billions of years ago. Telescopes act like time machines, allowing us to peer into the past and observe the universe as it was billions of years ago. The Hubble Space Telescope, launched in 1990, has been instrumental in this endeavor, capturing breathtaking images of distant galaxies. By studying these distant galaxies, astronomers can trace the evolution of galaxies over cosmic time. It's like watching a cosmic movie in reverse, rewinding the clock to witness the universe's early chapters. The Big Bang Theory has revolutionized our understanding of the universe and our place within it. It tells us that we are part of a vast and ancient cosmos, a universe that has been evolving for billions of years. The atoms in our bodies, forged in the hearts of long-dead stars, are a testament to this connection. The carbon in our DNA, the oxygen we breathe, the calcium in our bones, all of these elements were created in the nuclear furnaces of stars. We are literally made of star stuff, a profound reminder that we are not separate from the universe, but rather an integral part of it. The Big Bang Theory has shifted our perspective from one of cosmic insignificance to one of cosmic belonging. We are not just observers of the universe, we are active participants in its grand unfolding story. It challenges us to explore, to learn, and to push the boundaries of human knowledge. While the Big Bang Theory provides a compelling framework for understanding the universe's origin and evolution, it's not a complete theory. Many mysteries remain, questions that continue to puzzle cosmologists and drive further research. One of the biggest mysteries is the nature of dark matter and dark energy. These enigmatic entities, which together make up about 95% of the universe's total mass and energy content, have profound effects on the universe's structure and evolution. Another unanswered question is what caused inflation, the period of rapid expansion in the universe's first fraction of a second. The Big Bang Theory has provided us with a remarkable framework for understanding the cosmos, but it's clear that there is still much more to learn. The human desire to understand the universe is deeply ingrained in our nature. From the earliest stargazers to modern-day cosmologists, we have always looked up at the night sky with a sense of awe and wonder. The Big Bang Theory is a testament to this enduring quest for knowledge. It's the culmination of centuries of scientific inquiry, a triumph of human ingenuity and collaboration. But it's not the end of the story. The Big Bang Theory has opened up new avenues of exploration, inspiring new generations of scientists to push the boundaries of human understanding. With new telescopes and instruments, we are probing deeper into the universe than ever before. The quest to understand the universe is a never-ending journey, one that will likely continue for generations to come. And as we continue to explore the universe and unravel its mysteries, we can be sure that even more awe-inspiring discoveries await us.